Alrighty. This is the OmniSafe door barricade. I'm Michael Krajewski. I've done intro engineering design, principles of engineering, computer integrated manufacturing, and aerospace. And then I'm also in EDD this year. This is our EDD project.
Dim them down a little bit. It's easier to see. Dim the lights down a little bit so it's faster to see.
I'm fascinated with how things work. I like taking stuff apart, putting it back together, and kind of getting into the nitty-gritty of stuff. 17, I do various sports. I'm a member of FCA, and I really like engineering. I'm going into biomedical engineering for robotic prosthetics, and yeah, I just hope that goes well.
I'm Ian Erickson. One of the engineering classes I've been in is Intro to Engineering and POE, Physical Engineering. I really like engineering. I think it's fun. I like to take down, build up again. I don't know what type of engineering I want to go into, but hopefully I'll find that out in the next few years. I will be going to S&T during the fall, so it'll be fun. That's about it for me. Jacob.
My name is Jacob Cashwinkler. The completed classes I've done is Intro to Engineering, and I like engineering. I want to go into manufacturing after I graduate.
So the issue we're trying to combat is the casualties during school intruder incidents. As they become more prominent in the United States, it's sad. According to the K-12 drive, there's been 300 school shootings and at least 210 students killed and 248 injured between 1982 and 2023. So we at OmniSafe have designed a door barricade to kind of prevent school shooters from getting into the classroom. Yeah. So between 1193 school shootings happen a year, and between that, there's about 6 to 30 plus casualties. And it was due to inadequate barricading by the students and the teacher. And the intruder was able to get into the classroom. So to prevent that and kind of null out the factor of barricading, because it's timely, it takes time, and inadequate barricading was the biggest deal. So we're just trying to prevent that from happening. We did a survey. It was a Google quiz. We went to 6 different classrooms. We got about 56 responses. No, 62 actually. Okay. And it was simple questions. Can you barricade the door? If it does not lock, most of them answered yes. And school shootings becoming more frequent. There was a 10 for, sadly, they have. And how fast could your class barricade the door? They were saying 15 to 30 seconds. We did time trials during our EDD blocks, and it took about 45 seconds. And how fast can you lock classroom door? 5 to 6 seconds. But in reality, it took us about 20 seconds to run across the room and actually lock the door. And can you defend yourself against a intruder? A lot of people answered yes, but in reality you can't. I mean, you can't really do anything. Yeah.
These are some other designs we have found online, the whatever Google Patents is. What I thought this was like a little bolt that would shoot into the wall. This one is more of like this little box here has like a little thing to shoot out to block the door from opening. That's what I thought that was. These two have little wedges on the bottom to prevent it from opening fully or just opening at all. Oh, whoops. This, I don't know what that one is. This one, this little metal beam will shoot up into these holders for it so that it can be opened. It's just what
Here's our designs. Our design constraints. The product had to be affordable and reliable. It also has to fit in standard school doors, which is the width and height 2 and 11. How do you say that?
It's 2 inches by,
or 2 feet by 11 inches.
yeah, 2 feet by 11 inches.
And then 7 feet by 7.
By 1 inch.
There you go.
7 by 1 inch.
And then we also needed to be able to secure the door in under 5 seconds. In the future, we plan on creating the barricade to withstand a gunshot all the way up to a 12 gauge, and the lock would be constructed out of titanium, tungsten, and steel.
That's right.
So this are our brainstorm concept sketches. This was a design where you lift these up, it's spring loaded, and it would shoot into brackets on the door or into a hole in the wall on the side of the door. It would go about 8 inches to a foot into the wall or bracket. So kind of used as like a giant deadbolt. So that was kind of my design.
This is my design. I kind of plan on having so kind of with our lock right now, I kind of planned on having a lock at the top, so then if they try if they shoot like both of the bolts off, it would still be able to flip like that. So I put a design right here or up here somewhere, and it would stop it from rolling that way.
Sure. I just had the same thing sort of. I had barricades on both that would shoot out when when you press the button or activate it somehow. But we did go with that.
So this was our decision matrix. We based off of 4 core values: strength of the lock, accessibility, so easeability to deploy, child-proof, so a kid doesn't get hurt, and retractability, so how fast it is to disengage the lock. So Ian's design, when he went through it, it had the 5 strength because it was like 3 steel beams. And accessibility was 4. He was going to have it as a button. Child-proof, it's a button. Like anybody can press a button. And retractability, he didn't really develop a way for it to close. We had Andrew, he was on our team, but he left halfway through the school year. Jacobs was 4 in strength and 4 in accessibility for the same reasons. Child-proof, it was also a button, and retractability, he didn't have a way. And for my design, strength was a 3 because which was design we ended up going with. It's 2 titanium bolts that go into the wall from a stainless steel bracket and stainless steel casing with aluminum on the inside because it's easy to glide and aluminum stays like pretty oiled up for quite a while. And
This is our design. We were trying to bring it up the stairs, but it would not fit. So this is what we use for this is 2 sheets of plywood, about 6 studs, and right here would be our lock mechanism. We end up putting plywood sheets right here to help it lock with it. And then this is our little door. This shows the door. This shows how it would work. So so this is how you unlock it. that's how you would open it. So if the teacher had to, if they heard like a school shooting, they would come up to the door, lock it, and it would be able to stop it. So that's what this is.
That's the end of our presentation.
Any questions?
Any questions?
Now, how did the police open it?
So it's unopened on the inside. Well, it's unlocked on the inside. So when they do apprehend the school shooter or intruder, the students or teacher would just unlock it and it would be safe to escort out. One of the questions we faced with the project was the windows that are right here on the doors. If they were able to get in and try to unlock it. In the future, we plan on having spring powder with a 6-pound spring, so it deploys even faster. And if they got through the window, they don't have enough mechanical advantage to close the lock. And with what we were taught during school, intruders turn off the lights, hide in the corner. It's going to be dark, can't stick their head through it, they can't really see. And if they were able to get any of the bolts off, it would be the one closest to the hinges, but it's still like an 8-inch to 1 foot deadbolt that they can't get through. So thank you.
What a great presentation, thank you. So I have a question, survey, that's great that you guys did survey before you design anything. Who was your audience, the teachers or?
So our audience was students
Okay,
and
students.
teachers.
And
We kind of wanted a versatile opinion
yes,
on it.
yeah, absolutely, and good job, visualizing that as well. So you mentioned about it took a long time, right? That was the issue. With that, how much time did you guys reduce?
We actually, so the lock, because it's small and it's a key, in the heat of the moment, it'll take time, like that's precision to lock it. So with this, it actually saved about 10, 15 seconds.
Yeah.
And also good job bringing a 3D print, that's good, thank you.
Our buddy Scott 3D printed it. He has his
Right.
own little company.
Yeah, so Andrew Starks, he left halfway through the school year. He had the CAD modeling done, we just had to 3D print it, but none of us know how to 3D print. So my friend Scott, he actually has a 3D printing business. So we outsourced the CAD model to him and he printed it out for us. This was actually his first commission, which is really cool.
Great job.
Great job.
So one real quick question. So I noticed you guys said that you picked titanium and stainless material, which are all very strong for the door lock. Did you guys do any cost analysis to see
Yes.
how much something like this lock would cost?
So we kind of broke it down into the materials we actually need. So we would need about 10 kilograms titanium. That's just because it's relatively heavy. We use it weight, not really footage, which would cost about $109.50. 5 kilograms stainless steel for the casing and the bracket, which
50 bucks.
was about $52. And then the aluminum was relatively cheap because it's for the soft inward works. It was only about $10. So overall, we're looking at about $200 expense per door. So if a school had 100 classroom doors, it would cost a one-time payment of $20,000.
Very good job.
Thank you.
Thank you. I still don't see, though, how the police will be able to open it from the outside. Just give me a second here.
Okay. So 5 minutes before I
It's a
start.
technical difficulty.
When you're 5 minutes is gone. Up.
Oh, okay. Good morning, everybody. I'm part of the school's PLTW EDD class, and this is my project, Cold Cushion.
So my name is Kent Watlett. I've done every PLTW class offered at the high school, as well as CAPS. And my partner Cash, he has another school obligation, so he unfortunately is not here today. So our problem statement, everybody that drives has encountered a pothole at least once in their life. It's inevitable. They're everywhere. And they aren't filled fast enough. So we wanted to come up with a product to temporarily fill potholes. Every year they cause up to $26.5 billion in damage. So we're hoping to cut down on that number significantly. So this is our project justification. So our statistics, each repair that is needed is around $600 just from body damage, because a lot of cars will bottom out in some potholes. They'll pop tires, and you need a new tire, and that costs a lot of money. So we want to try to solve that. Approximately 33,000 traffic fatalities each year. 1/3 of those are involved from a pothole. So sometimes a car will hit a pothole, they'll freak out because you don't know it's on the highway, and you might swerve. And unfortunately, it does cause car accidents and fatalities. So these are some statistics from our local school. We did a survey where we posted around the school. 92% of people said that they have hit a pothole while driving, and I'm assuming the other 7% have never driven a car. Because we thought that was very surprising. Another question, this was actually more surprising than I thought. 35% of people that took our survey have had damage caused to their vehicle from potholes. For example, Mr. Dildine, our ceramics teacher, he has had to do multiple repairs on his cars because of just potholes alone. Road work is obviously a problem, and everybody is inconvenienced. So 92% of people said, again, I'm hoping the 7% have never driven a car, because still, it seems crazy to me. Potholes, they aren't filled nearly fast enough. I think there's probably 3 on my way to school every single day where they've been there for years. And they keep coming back, and they aren't filled properly. And then, obviously, everybody would be way more happier if there weren't as many potholes. So, yeah. So, current methods for filling potholes are obviously the traditional way: you tear up the road and you repave it with concrete. Other ways, you can use asphalt. Some people have tried to do foam concrete, which is similar to my idea, but it's a little different. And then there's also some composite concrete where you almost like take a 3D model of the pothole and then you can put something in it. So our design, we had these 7 constraints. It needs to be able to support the weight of all vehicles, because obviously if it can't, that's bad. That would almost make another pothole, essentially. It needs to be flush with the road so we don't make speed bumps, because nobody likes those either. Those are almost worse than hitting a pothole, because the suspension is not good for it. It needs to adhere to the cement or the asphalt without further damaging the road. It needs to be fast and easy to put into the potholes. It must be sustainable. It must work throughout all the seasons, and the fillings must be different. Like they must be able to fill different size potholes. So our design is this. It's a pod that is capable of housing a 2-part urethane pour foam. So I'll pass this around. This is a scaled up version. You can see there's 2 compartments in there that we would put the foam into. These are just some of our ideas to get, like we thought we'll make like a little sandbag, or like a pod that we went with. So this was our decision matrix to come up with a design, and we went with the pod because it seemed the easiest to mass manufacture. Yeah, you can hold on to that. And it it knocked out every single criteria. Very sustainable as well. So here is our actual product. This is made from PVA filament. It dissolves whenever it comes in contact with water. So our idea, you put one of these pods in a pot hole, pour water on it, the filament would dissolve, the mixture would occur, the two parts would come together, the foam would expand and fill the pot hole. Then you would come around with a crew, almost with like a snow shovel, but with a blade on the end. You would cut the foam so it doesn't create a speed bump before it finishes curing. So the object I gave you guys, this is our idea, but we would like to print it smaller even. Our 3D printers that we have at the school, we aren't capable of printing the PVA filament thin enough. That's just, we ran into that problem. So it does take a while to dissolve. So I had boiling water and I dropped one of these in. As you can see in the pod, there's blue and red food coloring. So this just shows that it will mix and it will dissolve. So here we have like our original sketch that we used for 3D printing. And then this picture is actually this little pod. So we would print two and then we'd melt them together to seal in the foam mixtures. So here's all our different, obviously you can see, yeah, the big one. That was our first design because we didn't really know what we were going to do. So we went with that. And then we started scaling it down and eventually we came to this. We also do not have the foam. It is rather expensive, but you can get 5-gallon buckets for about $30 a piece. And that's for both parts. And this filament, 1 kilo costs around $30 as well. And you could mass produce it it would be very efficient. Because obviously a 5-gallon bucket of the foam will last a long time if it's only being used this little amount. So since we don't have the foam, up here, I don't know, we have a pot. And since we don't have the foam, we thought, what expands? So we came up, we did some research, we have elephant toothpaste. So I just want to demonstrate what it would be like to the foam would actually like rise. So here I have potassium iodide and water, and then hydrogen peroxide and dish soap, and together they make elephant toothpaste. So the foam rises, and we would come back, obviously, and we'd cut the top. It does take a while because this isn't the actual foam, but we have done studies. The foam takes on average 1 minute to completely harden. So we would have to pour it, and then we'd have to wait just a second, cut it, and then it would be fully hardened. It's capable of holding up to 50,000 pounds of pressure, and it can stay in the road for 2 to 3 months with weather conditions. So this is perfect for the snow time. When the snowplows come through, they leave behind a ton of potholes, but it's too cold to actually fill them properly. This is a good temporary fix. So this is our demonstrations with the foam. We scaled it up first to get the proportions right, and as you can see, it made a lot. This is slowly rising. Hopefully it goes a little faster. And then, yeah, so my demonstration. And then, yeah, that's about it. That is our design to fix potholes.
How big is your hole there, and how deep is it?
So this hole, we actually used Quikrete and a Gatorade pot to form the pothole.
Okay, and you just poured that little bit in?
Just whatever, yeah. It's around, I think, 18 milliliters of hydrogen peroxide and 2.5 milliliters of potassium iodide. And that just alone, that would be the equivalent of the foam mixture, and this is what would happen with the foam.
And that will fill that hole?
Yeah, it should. Yeah, it's just taking a little longer today.
Do you know how much you have to put compared to
So-
one size hole?
So we would actually come up with multiple different designs. We could scale this up or scale it down depending on the size of potholes, because obviously they aren't all the same size. So we could produce bigger versions of these, almost like the big pod, or even smaller, according to the pothole. But we would run tests to figure out how much this would actually fill per capsule. So
Now, what's the boiling water?
the boiling water is just to show that this filament does dissolve. We can't print it thin enough to where it will dissolve on contact. So the boiling water is just a demonstration to show that it does actually dissolve.
But you wouldn't need boiling water at the site.
The truck would have to have boiling water.
Okay.
Yeah.
Now, you said the foam holds 50,000 pounds and would last, I think you said 2 months?
2 to 3 months.
2 to 3 months. So what happens to it after 2 to 3 months? Does it just
It
deteriorate?
deteriorates over time. And after the 2 to 3 months, you are able to almost just lift it out. You would have to, of course, dig a
Scrape it
little
out,
bit. But it would be, you could either drop it again, do the whole cycle again, or they could hopefully fill it with actual concrete. So, yeah.
Yeah, good presentation. I love the demonstration. It's
Thank you.
always fun to,
Yeah.
see what you're working on
Yeah.
and visual.
It was really fun to develop. Yeah.
Yes, yeah. So how did you come up with like this? I know that you explained about the,
Well, so-
statement, but
So first,
Yeah.
we came up with like our problems. So we were thinking like, I think one of our ideas was like something with a toaster. But then one of the pothole idea, we're like, there's so many potholes. Like that's actually good because it affects the entire world.
so it's just kind of based on your personal experience.
Yeah.
all the time.
And I personally would like to be a civil engineer. So I'm going to
Oh,
Mizzou this fall
Okay.
to major in civil engineering. So I thought
Yeah.
concrete,
Well, it's
roads.
definitely a need for sure.
Yeah.
Yes, very much.
Excellent
So.
presentation.
Yeah.
Very good.
Yeah, thank you.
You're very comfortable.
Unique.
Yeah.
You know.
They're well prepared for sure.
Yeah.
Good job.
Yeah, I like the top. Where did you get your figures on the accidents and that?
Those were a lot of the figures were from MoDOT itself.
Okay.
So they each, at the end of the year, they push out a ton of
Did
statistics.
you say that in your presentation?
I didn't.
Did I miss that?
No, I did not say that, sorry.
Well, if you do this presentation again, you might want to say.
Yeah.
These figures came from.
Yeah. I
Yeah,
will do that.
especially with the great data, so.
Yeah,
that'll help.
yeah.
Yeah.
Outstanding.
Mhm.
Good job.
Thank you.
Thank you.
Anything else? No. All right.
Great job.
And if, I guess,
Yeah.
This is our project ISO for engineering design and development at TBHS. So this is our team. This is me in charge of app development. These are some of the classes I took the last couple of years. I'm Wyatt Caldwell.
I'm Parker Quinones, head of documentation, and these are the 2 classes of engineering I took at school.
I'm Ian on presentation design, and we took the same classes.
So our problem statement, so obviously it's undeniable, online technology, digital age, it's growing rapidly, very rapidly. And to catch up to the opportunities people are turning to it to buy and sell items, Facebook Marketplace, Amazon, all those. And we saw this, and it's a great place to take advantage of because it's growing, it's only going to get bigger from here, and it's a very easy place to come up with new ideas and make them flourish. And here's some stats.
These were kind of hidden in the problem statement, but 800 million people use Facebook Marketplace globally each month, actually. So, and then in 2022, this accumulated to $3.25 trillion worth of e-commerce sales on the online marketplaces. After that, we conducted a survey at our school and went into different classes and gave them a survey. And off of that, 85% of the people here have used an online marketplace. And 63% of the people said that they were dissatisfied with the use of the online marketplace that they used.
And then for prior solutions, our biggest competitors are Facebook Marketplace. And for Facebook Marketplace, you just put something up for sale, people put an offer. It could take a while, and you'll probably not get like the right price that you want. and that's what ISO is trying to fix.
So our design that we came up with is called ISO, and we'll get into that in just a minute. Here's the process that we took.
For our designs, we didn't really know what to make because it's an app. So we basically just designed the homepage and logo. Down here, you can't see it very well, but we have the homepage right here. And then here's where you make the ISO. You put a picture of what you want, or like what is missing that you need, a description of what it is and the title of it, what it's called, and then the price range you want, and all that's negotiable, but it all comes down to what the people have and how much they will sell for, and then you just post it and it goes to the homepage here, and then you can chat online with the people you are selling to or buying from.
For our decision matrix, we tried to make something simple, easy to remember, and like this our staple. And we chose the middle right one, just the simple magnifying glass.
As our logo homepage. Design constraints?
For the constraints, we actually didn't know how to make an app before this, so we went to to learn online through online courses to make an app. And we didn't have any guidance from our teachers, it was all online. We didn't have any money from teachers, so we had to use some of our own. And we only had one school year, and we came up with this at the very beginning of it, and we developed it up until now.
All right, so the design process, the first one was choosing the software, very important for an app, because learning how to use it through the online teaching, and with time, surprisingly, it takes a very long time to learn how to code an app. So choosing the right software that could be completed in the amount of time that we had is very important. We ended up with going a software called Adalo. It's an app creator, and you'll see that in a minute when we demonstrate it. Stage 2 was instruction, taking the online courses through a studio called Upcode, and they had a representative sent to us. They taught us a little bit how to use Adalo, creating apps and stuff like that. And then stage 2 was working on the posting feature that you'll see when we demonstrate, just and you saw in the sketches, having posts on the home page that you can add images to, titles, ideal price range, description, and all that. Stage 4 was chatting feature. Merging posts with chats was a very difficult thing to do, but with the time that we had, we were able to do it, so you can chat with people after posting it. And then stage 5 was troubleshooting, always with online things. Bugs, glitches everywhere, sometimes hard to fix, very hard to find, but with the time that we had, we were able to get all those bugs out. And this led us to our final design, called ISO, an acronym for In Search Of, which is kind of the framework for what our app is. So whereas Facebook Marketplace, as Ian mentioned earlier, is where you have something you want to sell and you put it on there and people can buy it, but sometimes it can take too much time, the price isn't quite right. We have it to where you post something that you want and people can be on the app and fulfill the order that you want, make it more convenient for buyer and seller because maybe you had something you didn't think about selling but you don't need, and you can make a little extra money, getting rid of it, clear out your house a little bit, and the consumer can get a more accurate and cheap version of what they were looking for. Here's the build materials.
For the materials, it's not too much. We just personal computer for making the app, cell phone for testing mainly, and the software that Wyatt said was Adalo, and Upcode was the classes that we took to learn app making.
And feature modification, something we learned from our surveys, we had an open prompt saying, what is something you are looking for from the current choices that you have for online resale? And a large portion said anti-scam technology, which is very perfect. In an ideal world, it's very nice to have, very difficult to do in process, so we would need more time to come up with that technology because scammers are people too, and it's very hard to filter that. A following friends feature, so that maybe you have someone that's always looking for something and you have a lot of stuff or something like that. You can follow people, be friends with them, and be updated when they post something. And then as well as our ISO format, which is kind of the reverse of Facebook Marketplace, doing a marketplace as well. So instead of just cornering the market on the ISO format by flipping Facebook Marketplace, we can do that as well as Facebook Marketplace just to create a better and all well-rounded version of the marketplace online that we have. These are our references, pretty short, for our software and our teaching from Upcode and Mandala. We'll do the demonstration. Right now, it's currently on my phone. You need to stop airplaying this.
Room in Seago's room. 303. Yeah, black.
So this is what you will see, I guess, as a user, and this is the prototype. It is not the final design because, as we mentioned earlier in the constraints, it does cost a considerable amount of money to actually post the app to the App Store and have it published. So this is the prototype from Adalo. So when you open up here, you can go to ISO. Here's the app on the home page, and this is all of the posts that we made while presenting to the students out there in the mezzanine. And so basically how it works is, as you can see, there's a couple examples. You have symbols, shoes, maybe collections that you have that you can't find anywhere else. So what you would do as a user is you create an ISO, that's what it's called, an in search of, just for branding, stuff like that, get the name in people's head. And the product title, so whatever product you're looking for, maybe you're looking for a desk, you know? And your description is maybe you want a certain size, 15 by 10 feet. You know, anything you want, maybe the brand of whatever item you're looking for. And then your ideal price range, so what you're willing to pay for it, and obviously that can change through the chat feature that we'll show in a minute. So maybe it's $50 you want for this desk. You can add images to your ISO after that, and as many images as you want. You go to your photo library. I'll just go to whatever recent photo I have. There's a lizard. And so you add images to post. You can add multiple images if you want, and you publish it. And there you have, on the home page, you have who posted it, your title, description, ideal price range, and how long ago it was posted with your images up top. And then you can chat. Obviously I can't chat with myself because I just posted that, but maybe I want to chat with this person about Jordan 1s. Maybe I have and they don't fit me anymore maybe, and I just want to make some money on it. So I can go chat with this person, and maybe I just say, you know, I have the Jordan 1s, you know? And you can chat back and forth about price, whatever it is, send your chats, whatever, and that'll show up in your recent chats. And then you can go back to your home, that's settings. Go back to your home page, obviously you have settings, there's no profile picture for this account, you just created it, but you can change all your stuff in settings, and that's the presentation of our app. Any questions, guys?
Pretty cool. Yeah, so how does ISO make money? I mean, obviously everything's a business, so you gotta make money. So do you guys charge for the service? Do you charge for the app? How do you sell ads or?
With well, yeah, obviously marketing with ads of other companies, including ads on there, is a large part of revenue. And also the App Store, through downloads, you make money through people downloading your app and using your app from the App Store. So that's another way you can make money. And that's another thing, an app called Poshmark, or website. Where they take 20%, or I think it's some big chunk of your earnings like that. We do not want to do that because that makes it non-user friendly and less likely to be downloaded. So, but yeah, the ads and the downloads off of the App Store would be main revenue.
Cool idea.
Yeah, great job. And you mentioned that you did not have any experience prior to this. So that is pretty awesome that you guys took your time to learn and get to the point you can give us a demonstration. So pretty good job. A very interesting idea. Yeah, very interesting idea. So did you guys have like personal kind of struggle with online work?
Yeah, so we have this old truck, and it's a 2005 Chevy Silverado, and the right headlight got busted out by a tree. And I mean, we look online, it's you go to the manufacturer, $1,000 for a headlight, absolutely insane, arm and a leg. And at that point, it's not worth replacing. Go on Facebook Marketplace, there's not gonna be someone posting 2005 Chevy Silverado right headlight on Facebook Marketplace. But maybe there's someone out there with a 2005 Chevy Silverado that has a working headlight, that maybe the car doesn't run, like, hey, I'll get rid of the headlight for $100, $50. And so you post on there that you need this headlight, and someone can, you know, do that, and that's not something that would happen on Facebook Marketplace, or if you wanted to buy it from the manufacturer and waste a lot of money. So just, there's a lot of things like that, as well as like collections of the coins all the way down at the bottom. Like maybe you need specific coins and you're not from that state, or you know, it's something that someone else had. You can look for it, people can be like, I had that coin, maybe it was your grandpa's, maybe you just don't collect things anymore. And so you can fulfill their order, and it's quicker, faster, easier, make some money, whereas Facebook Marketplace wouldn't do that.
Yeah, thank you for the demonstration. Pretty neat.
Okay, we're good. All right. So this is our project. This is CAPS at Toyota Bodine here in Troy. My name's Aiden. I'm a senior at Troy Buchanan High School here.
I am Andrew. I am a junior at Troy.
I'm Brayden Jones, and I'm a senior at Troy.
Alrighty, so I'll go ahead and start us off with our little roadmap that we've made here. I'll go through a quick little introduction here. So introductions was one of the first things that we did here at Toyota Bodine, and we had a general meeting, a site tour with everyone. We got to meet who we were going to be training with, and we went ahead and did our team training, so we learned about safety. Apparently, you know, we have to avoid putting chilling drinks in dried ice. Apparently that's a thing. We had to go over skill analysis, and we did our project overview after that. Then we went ahead and made our CAD prototypes with our CAD wizard over here, Andrew. We had our review meeting shortly after that to review our design and go over any flaws that it might have, be able to adjust anything that we might need to adjust. We had our prototype development before we went into our final proposal, and then drawing development and final revisions. All right. So this is our AGV project introduction. So the AGV right here, basically one big giant Ozobot. So it kind of just runs off the floor with some grids, some tape, and it follows that. The AGV is responsible for transport of parts throughout the entire manufacturing process at Toyota. And Toyota currently maintains around 140 of these robots.
The existing problem with the repair station that they had set up is it just took too long. Took like 20 minutes. They wanted that cut down to way shorter than that because it's taking up way too much workspace. And it was unsafe. Some of the bolts that were attaching this repair station could come loose because the entire plant's shaking because they just have so much machinery in there. Given restraints, the AGV weighs 250 pounds, which is a lot for a robot. It has to rotate 360 degrees so they can repair every single time. And needs to be a safe removal process, obviously.
Alright, so moving off those constraints, we formulated our promise statement here. I'll just read this out for you. The maintenance process used by engineers must be intuitive and efficient to assure safety of AGV and all personnel involved. And a big part of that was ensuring safety in the maintenance process. That was the whole goal of this project, is the current process was simply not safe. And then on the back end of that, just reducing the time that this process took. And in the end, I think we're happy with what we were able to come up with and really meeting both of those values, and I think it satisfied our constraints there. So one thing to mention before we kind of move into our project that we were given is references on this were not as much as an online research thing. It was more of an interview process. We met with a team of engineers with various backgrounds, various degrees, and that's how we were able to really gather information and our insight for this project, as well as using prior engineering knowledge. And then that's how we applied that to this project. We did not know everything coming into this, so we had various resources and a very helpful team at Toyota, and we were able to really expand off of that and create a successful project. So we'll start off here.
We'll wait for this to pass.
Pause.
What is school?
So just starting off what we were given, you can see these two gray vertical bars here are what is on the AGV and what we were given. This blue plate is a motor stand jig that is rotated with an arm on a gear reduction to allow slow movement of the AGV and give it rotation. Again, you can see those 4 bolts in these locations here. That's what was coming loose, and that was our problem with the existing solution, as well as those 2 large plates were coming together, and that was a big get your finger, get any part of your body. It was a big thing, and some of our research that we had looked into was just the overall cost of the worker and then maintaining injuries and really a cost for the company, and that was a big part of why safety needs to be ensured in this process. Okay, so we'll kind of move into our first prototype here. We started off with a little bit more of a complicated design, and we were given a lot of constructive feedback on that from our team. We had 2 forks that would slide into pockets.
You can see the forks are the green pieces on this cat, and then it would slide into the blue and yellow pockets, and then be secured by this gray pin that you see here. And the main feedback we got from that was just it being bulky in general. And while this was a good solution, we would continue to build off of that for our next design.
Our main design changes after this for our next and final design is that we thinned it down a little bit because it was hazardous. The previous design could bump into people, cause workplace injuries, which would be very bad for the company. We also made it easier to use because that old design, you'd have to have 2 trailer pins, and you have to line them both up, which is a pain, which would take you multiple attempts. Really want to be good for you, for time-wise. And it could possibly take 2 workers, something that we found out. And setup time. Took a while to set up the old design, so we made that a little easier. We added a collar later in one of our later designs, so you didn't have to really line up as much. It just would just go in there, be a lot easier.
So kind of explaining our final design here, you can see it is a lot more simplified than what we started off with. We went from various forks and interlocking pieces to one simple male-female end coming together. The blue and red pieces here are plates that are mounted to our actual maintenance stand. That gray piece is the male end to the system. The white piece is a collar, which allows it to line up perfectly each time and not overshoot and keep your fingers out of the equation there. And then that yellow piece is the piece that is going to be mass produced and can be applied multiple times, with that green piece holding everything in place. The main benefit of this is that if that green pin is not in place, this is a free rotating and safe system compared to the prior solution, which if not properly secured was dangerous. Gravity locks this system and makes it safe throughout any circumstances.
All right, so we have some pictures here of our final design, and like he said, one of the best parts of the design was that even if you forgot something, like we had issues with previously with it, with bolts being forgotten, lost, or just not tightened down all the way, was that if you forgot the hitch pin for whatever reason, it would just freely rotate, so it allowed the robot to stay stable and wouldn't fall off, causing grievous injuries possibly. And one of the things we implemented at the end was a hitch pin that was a locking hitch pin, so you had to press a button so that you couldn't physically remove it while the robot was upside down or lifted. And it was changed to the post itself, so all it took was one quick glance down to see that you were missing your hitch pin if it wasn't in while you were trying to lift the robot. And then this is our final, like I said, this is our final design. So this is us lifting it and rotating it and checking it just to make sure it worked, see if anything was broken, see if it would hold all the weight. We balanced it and we bounced it just to make sure. So. And then this is some more pictures. This is a close-up of what we have here. This is more akin to your trailer hitch. So this is a hitch pin design, so it's slide there. As Andrew mentioned, we do have a collar on there. It's right there, so to prevent people from being able to push it farther down, so you wouldn't have to spend minutes trying to sit there and readjust the whole robot. And then, yeah, that's just a picture of us lifting inside. Real quick, we have bill of materials for you guys. So this really just took 1/4-inch steel plate. There's a lot of that lying around, and it was fairly easy to do. I even had a hand in being able to make some of this. So, you know, a high schooler with very limited manufacturing know-how can manufacture this for 140 plus robots. I think that's a pretty cool feat. As well as 1/4-inch steel pipe, stainless steel pipe. And then we bought a quick release pen from Granger. That was about the only problem that we had along with our project, was that the shipping took a little bit. So in that photo, the previous photo, you probably noticed that it was just 2 bolts. One of those bolts is there permanently, just to make sure that that billet that we had there, the bullet nose, would just stay in place. But the other bolt that was on the EGV itself was supposed to be a hitch pin, which we didn't have at the time. Thanks, Granger. And then we just had some Krylon paint and primer, so we went ahead and painted everything to make it look really nice for all the people that we were going to be presenting it to at Toyota, and as well as you guys. And then PLA, because we actually 3D printed some prototypes. We did not print them because they were early prototypes, so they were kind of scrapped. But ultimately, that's something that I thought was really cool with the whole project, was that it was a very practical thing
that it was very engineering minded. We were given something to fix and we were told to go use our brains to try to figure out a unique and original idea to try to fix that problem. So a lot of the references and stuff are strictly just us and engineering members that have given us feedback. So. And then we had an extension project that we reviewed after our final proposal of our AGV itself. Toyota wanted us to track and create a maintenance log for all their essential parts, but most notably the AGVs themselves. Some of the problems they had with the AGVs was that they weren't being maintenance as a preventative maintenance. They were maintaining whenever they broke. So they had a lot of these AGVs lying around that they hadn't been able to get to, and it was just really costly and not very time efficient to be able to put all these robots on this stand like it was before. So we wanted to create a maintenance log to be able to see what robots would break more than others and where we may be in the shop. So if this robot's breaking more than this robot, we can find out what's wrong with this one and we can nip that in the bud before we have problems with it. It's kind of like oil changes. You want to get your oil changed before your car breaks, never after. So, and this would just be able to help them put robots on the system a whole lot faster. But this was just an easy way of tracking these robots, and we just use an NFC tag for that.
Okay, so just moving into our final design of that tracking system. It was a pretty simple implementation. We were able to just expand on the prototype that we had previously developed. You can see this NFC tag in the top here. That's something that can be scanned by various different devices, such as your phone. And then, along with a team of engineers at Toyota, an app is being manufactured to be able to take that data from that NFC tag and then transfer that into an actual maintenance log. That way you'd be able to track that over time rather than just guesstimation of when things are broken and fixing them at that point. And then on the right here is just that CAD drawing. That's something that was sent off after our final prototype to just get that on there for final manufacturing of the piece that's going to be applied to all the units. And just some of our final data here kind of show off our results to you guys. We're able to reduce an estimated 75% of time off that process, which then correlates to about $22,000 a year in annual savings for the plant. A big part of that is, as you can assume, the Toyota line shutting down because of AGVs not being functional is probably not something that's good for the company. So being able to have these AGVs up and going at all times is a huge deal with the plant. It really just keeps the place running. So being able to maintain these properly, as well as having more time allotted for maintaining these, is something that our product was able to provide for that.
This also isn't including anything like worker-related injuries or the fact that a lot of these robots are backed up and there's kind of a graveyard that is building up. So this isn't including any costs that would be related to fixing all of these robots at once, as well as I believe it was an average $10,000 for a worker-related injury that would involve a hospital visit. But I imagine crushing your hand between two steel plates with 250 pounds is probably going to be a hospital visit. So that's pretty safe to assume that.
Do you guys have any questions or feedback?
Could we see the final product again?
Oh yeah, sure. If I can figure it out. There we go. All right. Well, let's wait for it to work. There we go. Any questions?
Interest. Yeah. This is near and dear to your heart,
Yes,
huh?
absolutely, absolutely. Yeah, congratulations, yeah.
So like I mentioned,
Yeah.
there's a bolt here,
Yep.
so that's supposed to stay there. That's going to be permanent. We'll make sure no one can remove that, and it'll all stay there and be ready to go whenever the next robot comes in. But then this one was one of the moments that we had with Granger. It took a minute for it to ship, so we didn't get a picture of the actual hitch pin in there. But I can assure you it's definitely a faster and more efficient process.
What an opportunity to get a real world experience and a real world
Oh yeah. That's one of the things I really like about this project. I took EDD last year, and EDD was also really fun in its own right because we basically had the same autonomy to be able to do our own project ideas. But a lot of the projects, at least for my year, was kind of building off of already existing solutions. This, as far as I know, was strictly just us coming up with really bad drawings on whiteboards, and he somehow turned it into something that looked so much better. We spared you guys with the really bad drawings there. So, but it was just a whole lot of fun to do. Like, just being able to give like it was difficult, I'd say. It was difficult.
We had some very directed feedback meetings with our team of engineers, but it definitely got us, it got us to our final solution eventually.
Yes, I believe we went through 4 prototypes before we got to our final solution, but ultimately I think it was just a whole lot of fun getting there. Just being able to go, okay, this didn't work, build something new. It wasn't a grade on paper, it wasn't a no, this is wrong. It was a, we want this to be better, we want this to be more safety minded, we want this to be more efficient. How can you make this design that you already made better? And that was just something that I really liked. And we get to see the fruits of our labor here. This is something that is implemented. As far as I know, Toyota is implementing this on all their robots, and they're currently using our prototype for training.
Just out of curiosity, what maintenance issues do you see with the robots? Or what are they maintaining on that?
So under the robots, they had belts. You probably can't see it, but this is belt driven right here, this big wheel. Yep. So they have rubber belt underneath that. They need to replace and maintenance those because they can get dry rotted. It's a really dry building. And the other issue is that these casters, they're all greased. They have grease points, so they need to grease those somewhat regularly, make sure bearings are all okay. And one of the things that we found out was that our actual prototype robot, whenever we flipped it around 360, it was actually missing bolts on some of the casters. So there was already issues that people were already looking at. They're like, oh my God, this is missing things that we wouldn't have ever known if we didn't maintenance this.
Yeah, great job.
Great job.
Yes. And I was going to actually add that we are going to apply this to the rest of the robot, which is 140. I am so impressed how hard you guys worked. And as they mentioned, we went through some review meeting. You get real feedback, right?
Yeah, exactly.
Right? Because you go in there with the confidence.
Engineers are usually blunt too.
Yes,
so. There's no filter there.
Very straightforward. Hey, looks great on the paper, great job, great design. However, because XYZ in a real working environment, this does not work, can you improve? And they really took it so well and took the feedback and make improvement for the next visit. So then repeated the process. And then there we actually do have a final prototype that it is actually functional and we can apply the rest of the robot. So I am very proud of you guys. Great job.
I think we brought some things to the table too with us as well. He is very CAD and technically minded.
Yeah,
and it was, I think we blew away some of the engineers in some of those reviews with his CAD abilities. And
they definitely gave us some feedback on top of that. That was the biggest thing of this experience that was great, is being able to work with a real team of engineers rather than just your theoretical ideas that could be applied. This is the first time that in school we've been able to see actual application of a project, and that's why this is such a big deal to us that we were able to actually apply it. And now that we know every robot that you see driving around on the Toyota floor is going to be carrying our prototype on it. So.
Cool.
And as you may know, since you work in a more machining facility, we had some feedback with the manufacturing department. He was trying to get his constraints within thousands of inches. Oh, yeah. And when we went to the manufacturing department, he was like, we don't need that. No thousands.
Any other questions for us?
Yeah. Very good job, guys.
Yeah, good job. Was that your first time in a manufacturing environment?
We did some tours. We did some tours of Chase here in his facility, but for the most part, working in a manufacturing facility, yeah. I took pipe linkage, so I did welding before, if you consider that a manufacturing facility, but nothing like a professional building, head gaskets and stuff not head gaskets, but heads for cars and stuff or something.
Because of CAPS, we had taken a lot of tours at different manufacturing sites, but Toyota was the first time we had experience. We were actually in that and seeing the process day to day rather than just the one-time site tour. So that was definitely a different experience to see.
What an opportunity.
Yeah,
of course. And you guys did a great job.
Yeah, thank you. Good job, guys.
Great job.
Thank you.
My name is Faith McClellan, and I didn't really invent it, but I made some modifications to a storybook wall. So over the past 20 years, there has been a 50% decline in how often younger generations are outside. On average, it's about 7 minutes for ages from 6 to 17. And this is concerning because being outdoors really helps with your cognitive development. It can generate curiosity and creativity and your critical thinking skills. And literacy skills have also had a hit. For over the past 20 years, they have decreased significantly. About 40% of kids read at a basic level and even struggle with that from time to time. So why not try and tackle both of these issues in one design? What if you made a storybook walk to include reading and the outdoors in order to entertain kids while helping them grow their academic skills? So for my statistics, I found that the average child in America between the ages of 6 to 17, they spend just about 7 minutes a day outside, representing a 50% decline over the past 20 years. Not only, but approximately 40% of students across the nation can't read at a basic level. And 30,000 children trap their fingers indoors each year, and about 1,500 of them need surgery. That may seem like useless information, but for my design, I wanted to include a way for students or children to be able to open this storybook walk up and get more hands-on with the papers, so I didn't want them to be able to trap their fingers and increase to the statistic. And from my survey, as we can see from the 3 larger circles of 100%, this is when I asked people from our community currently if they enjoy taking walks with their kids or grandkids, if they think that physical health and literacy should be combined into one thing if it can be, and if kids should be more hands-on in learning. And they all said, yes, 100%. And I also asked, do you ever worry about kids getting hurt when they're going to grab something or getting curious? Because children can't watch their kids all the time. That would be impossible. They're constantly running around. And when it comes to in a park, that's their time to be free. So what if they ran around and they could have gotten hurt from this storybook walk? Well, that's why I asked if they ever worry about it, because this shows that this is something I would try to implement in my design, to try and take away some of that worry. And most of them said all of the time and yes, with a 30% saying no. I also asked the question, have you ever heard of a storybook walk? Because while not a lot of people in our community realize it, we actually have 1 or 2 implemented into our town already. And this one I'm going to show you is actually going to be implemented into the park inside of the Legends. And most of them said no, 8% said that it sounds familiar, and about 39% said that they knew what it was, but majority, they had no idea. So some prior solutions range all over the world. While there were no official patents, they are something that take place everywhere, from Colorado, North Carolina, and the St. Charles Community Park. The main thing that I didn't like about any of these designs, which you would be able to see in these 3 little texts down here, is that I didn't like that they were straight up or they weren't accessible to the entire family. Because parents, it's a little hard to get down on our knees or to read at a lower level sometimes. So it wasn't really accessible if you wanted to help them out. I also didn't like that the students couldn't get hands-on with the pages and hold them or trace their finger over it if they needed, or even it could get too crowded because there's not enough to go around for everyone there. So I created a couple of designs that I thought would help this. As we can see here, my main goals were safety, to have a low cost, to include hands-on aspects for the children, and for it to be family friendly so that everyone in the family could enjoy this. My first design, I wasn't entirely proud of. I thought it was better because it was tilted back so the kids could still be able to read it, but so would the parents without having to get down lower to the ground, which could hurt joints. But there was no opening mechanism, which wasn't really what I wanted for the hands-on idea. The second one, which is the one I ended up going with and making some future modifications to it already, is tilted as well. Both of them are tilted, and it would have a latch on the side to be able to open it up, but there was no way to ensure that it was being safe from a simple sketch, and it just wasn't fully what I was looking for in order to create a beautiful thing for this community. And the third one was more straight up like the ones I showed you on previous slides, which isn't really what I was going for, but it did have the number along with the second one to tell you, just in case you noticed them a little later onto your walk where you were, which I think is a little bit more family friendly as well, because kids are kind of all over the place. You may have missed it a time or two when you're trying to figure out where they're running off to. So, as I said, I did elaborate on the second one, which you will see here. I did include a lot of breakdowns on this, but essentially it would be a sort of opening design with a locking lid support hinge so that it would open as much as you wanted without falling right back down. It would allow your kids to open it up after you unlocked it from the swing latches on the sides, on both of the sides, so that the parent would have to reach around and open it for the children, and then the children could even push it up, or the adults, and it would stay in place so that it didn't crush their fingers, to increase that previous statistic I told you. Not only that, but it would have a rubber seal on the inside of the wooden frame to increase the chance of weathering, just so that that doesn't affect the papers as much. And there's a wooden ledge to hold the papers as well, and L brackets on the side to increase the stability of the frame. Because we walked through one a little earlier this year with caps, and the frames had been a little busted, which is something I was trying to avoid in my design, so that it was just a little safer. There was no risk of getting hurt or having any splinters in these children. Step up onto this and see the different pages better. Not only that, but something I didn't mention before is I would like to include multiple laminated pages of the storybook walk in each, just to decrease that crowding, so that if one kid is looking at the page, they could hand another kid that page and grab another one from the storybook walk itself. And this is where I got all of my information from, just my references for all of my statistics. Are there any questions?
Pretty neat idea. Why did you make the whole telescope?
I didn't think about that in the moment, and it is made out of wood, so I'm not sure how that would fully be able to be done while keeping it steady.
You said that you're in your research, just curiosity, the 50% decrease in children spending time outside, did it say any indications of what's causing that, or what's keeping the kids indoors? I'm assuming it's got to be devices and gaming systems and stuff like that, but I was just curious if whoever had the research, they did any.
Yeah, that's actually exactly what it's from. It's from iPads and gaming systems. Every kid is wanting to spend more time inside using those sorts of things. That's why I thought that a hands-on design would be a little bit better for the kids, because as they're hands-on with their devices, they could be hands-on with this in a similar fashion and kind of try and relate that.
Really, the number from my childhood is completely opposite. Completely. You know, we didn't spend time inside.
Yeah, like me.
You got kicked out.
Yeah.
You probably could incorporate in there the illnesses from staying inside, from not getting sunlight, from not getting the fresh air.
It definitely does affect a lot of that, because a lot of illnesses actually come from your cognitive development, which is what being outside helps improve.
Good job.